All right, so first thing we're writing here, just a little review. If two polygons are similar, so triangles, rectangles, whatever, if they are similar, then the two things that we always know is all corresponding angles are congruent. Okay, so we've definitely been using that idea. And then all corresponding sides have the same ratio. So if one side is twice the other side, then that would be the ratio for every single side in two similar polygons. So all corresponding angles are congruent. All corresponding sides have the same ratio to each other. We're going to be dealing today specifically with triangles. And there are three ways that we can prove triangles are similar. You're going to put one of them, let me not write that too big, as what we call angle. So write down angle, which we're going to shorten to AA. Okay. We can also put side, which we're going to shorten to be SSS. And then the third and final way is you're going to write side, angle, side, which we will in the future just write as SAS. So we'll use those abbreviations long term, but that's what the abbreviations are going to mean. So angle, side, and then side, angle, side. All right, and then we use this little guy to distinguish between the idea being similar and congruent. So congruent, not only the angles congruent, but the sides would also be congruent. And in similar ones, the sides aren't congruent, they're not the same size. All right, so down here, where it says angle, that's just asking in the parentheses, what's the abbreviation for that? We're going to write that as AA. What this is telling us, let me mark some corresponding angles here. So those guys are corresponding. These guys are corresponding. What angle is saying is two angles in one triangle are congruent to two angles of another triangle, then the triangles by themselves are similar, and we would say that because of the angle theorem. So what that simply means is if I know that the purple are congruent and the blues are congruent, wouldn't that then pretty much tell us that this third set that isn't marked would have to be congruent as well? All right, they'd have to be. And we know then all three of them are congruent. So what that kind of basically proves is this whole all angles are congruent. All right, so if we know that two of the three are congruent, then that guarantees the third one is congruent. Therefore, we know we have similar triangles. All right. All right, side, angle, side. So that's going to be SAS. Why is that writing like that? So that's our abbreviation. So when we use SAS, then we can use side, angle, side similarity if two corresponding sides are proportional. So let's do this. This guy and this guy are the corresponding sides. And then I'll mark the top ones. So this side and this side are the corresponding sides there. It needs to be two corresponding sides that are proportional. They have the same ratio. And this is important now to understand. The included angle. So if I label these angles 1, 2, 3, 1, 2, 3, which angle is the included angle by the blue and the yellow side? Angle 1, 2, or 3? So what angle is created by the blue and the yellow hitting each other? Angle 1, right? So angle 1 would be our included side. That's what this means by the included angle. It's got to be the angle formed by those two sides that we're talking about. All right. So if we know that these are proportional to each other, the blue to the blue, the yellow to the yellow, and then these angles are congruent, then we can prove side angle side, and we know those triangles are similar to each other. All right. And then the third one, pretty straightforward with this one, side, side, side. If all three pairs of corresponding sides are proportional, so they have the same ratio to each other, then we know the triangles are similar, and we would say because of side, side, side similarity. Okay. So if this, we'll use the one I used the other day. If that's 2 and this is 4, actually don't do that. Let's use some ones that actually will, yeah, we'll pretend it's a right triangle. We'll say 3 and then 6. So that's twice as big. If this is 4 and this is 8, that's twice as big. If this is 5 and this is 10, notice how they're all twice as big. That's showing that all three sides have the same ratio to each other. So by side, 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 we know those triangles are similar. Okay. All right, so here's how we're going to now do this. It says, are these two triangles, ABC and XYZ, similar? So is triangle ABC similar to XYZ? And then if yes, you're going to state which of those three reasons above. When we think about all these different options, notice in here there are no angles marked whatsoever. So if we look at our three options, so if I revisit these guys, I should go to this one. Notice how this one references angles. This one has an angle. We don't have any angles marked. So what we're probably relying on for this first one is, can we show by side, side, side that these are similar triangles? So here's how we're going to do this. I'm going to take the yellow sides first. I'm going to do B to A and then Y to X. We're going to see what their ratio is between each other. So I'm going to do 6 compared to 4. And I reduce that down to be a 3/2. So all three sides better have that same ratio to each other. So if I go to the next set of corresponding sides, so I'll do this side compared to this side. Notice how I put the bigger one over the smaller one, so we want to make sure we maintain that relationship. I'm going to put 9 over 6. That would also reduce to 3/2. So far so good. 3/2 here, 3/2 here. Our final one would be the bottom, 12 to an 8. So let's take 12, write it as a ratio compared to 8. If I reduce that, 4 goes into both of these. It goes into 12 3 times. It goes into 8 twice. Notice how they're all 3/2. So we would say yes if the question is asking us, are these similar? And we would say, because all three sides have the same exact ratio, we're going to put side, 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 and then you put the little squiggly right there, so it says side, side, side similarity. Okay, yeah.
You can have to solve for the other two or three.
You do.
Okay.
Yep.
And that is with angles that two of them are.
Correct.
Okay.
Correct. Yep. All right. So that's what we're doing when we're looking at these. So if you look at letter B, let's look at what's marked. So I have this side is marked. This side is marked. But we also have some angles, correct? So it's probably not going to be side, side, side. We have these angles in here. So let's look at the next corresponding set of sides. So here's this side, and it corresponds to that side. Let's first test those ratios. So let's go 6 compared to 3. That is a 2 over a 1. And then do 10 compared to 5. Also 2 over a 1. But we don't know this third side. So that's not marked for us to right away just do a ratio. But if you notice, isn't the angle included by those two sides? So this guy and this guy, isn't that the angle formed by the blue and the yellow in both of them? So this is the included angle. So this allows us to then check this side angle side one, where we talked about the included angle. That is definitely the angle included by those two sides. So if we now go down, if that angle is congruent, is it congruent? Yes, obviously, right? It's just told they're 90 degrees each. So this is side angle side. Both sides have the same ratio of 2 to 1. The included angles are congruent. So we would again say yes, and in this case, we would write side, angle, side, similarity. That's how we know those two triangles are similar to each other. All right. All right, so letter C real quick. See if we're processing any of this. See what you think for letter C. Got it back there, Cam? Yep. All right. All right, so as we get to this one, since we're on a new page, these are our only three options right now. We got to be able to prove one of these three in order for us to write yes to the question that they are similar. So just understanding, if we look at these two and what's marked, what we kind of want to understand, are we going to be talking about this? Are we going to try to prove this? Or are we going to be proving this? So of these three, so I'll call this option 1, this option 2, this option 3, just understanding what's marked, what's given, which of those three would be the one that we would be trying to look at to determine? Yeah, it's got to be number 3, because we have the angle. So this angle right here and this angle right here is included by the two sides around it. So this should be the one that we are trying to identify. So let's talk about the angle. Are those angles congruent to each other? Yeah, because they're both what measure? 90 degrees, because they're both marked with a little square right here. So this is a 90-degree angle, this is a 90-degree angle. So we've satisfied that. The last thing that needs to be true then is this side here and its corresponding side here. So 8 compared to 5 better have the exact same ratio as, come on you, the 4 compared to the 3. So, because these are also corresponding. Now, these don't reduce, so we may want to write these as a decimal because you may or may not know if this is true or not. So a decimal might be a good way to kind of do this, throwing this into the calculator. Is that what you did, Kim?
That's what I was just asking.
Yeah, that's what I would suggest to do. So if I did 8 divided by 5, what's that give us, Kim?
1.6.
So this better give us 1.6 also.
That gave us 1.3 repeated.
Good. So that is 1 and 1/3. So did these guys end up having the same ratio? No. So this is when we can't prove one of those that we would then say no. All right. All right. Letter D. Just understanding how we would attack this at the beginning in terms of which one are we trying to prove. Look at your three options here. So option number 1, option number 2, option number 3. Look at the two triangles. Look at what is given to you, what is marked. And then it should be pretty clear, I would hope, which one you're going to try to prove. And then see if you can prove it or not. And if you can't, then it's a no. What time? 35? Or 05? Oh no, 35 minute classes, right? Yeah, for sure, for sure. God, I'm getting old. All right. Running a little short on time here, so let's kind of get this going here. Do we all agree that those are all three sides that are given to you? So we are trying to prove this one right here. We want to see if all three sides have the same ratio to each other. So yellow to yellow would be a 9 to 6. That does reduce nicely down to be 3/2, or you can throw it into the calculator and get 1.5, whichever you prefer. If I go purple to purple, that's going to be 12 over 8. 4 would go into each of those, and this is 3 over 2. So far we're good. And then if we go blues to blues, did that also give us 3/2? Yeah. Or 1.5. Since those are good, you would say yes, and you would say side, side, side with a little similarity sign. Okay. All right, that's it. At home, go have a good weekend. We will pick up with this on Monday. Yeah, so have a good long weekend. It's nice coming back to 4 days. I'm not going to complain about that. Okay. See you, Saleh. I'm gonna turn him up here.
4-day week, back end. That Monday off.
Yeah. All right, guys. Have a good weekend. Well, thank you too.
Right. Wait, we're off tomorrow, right?
We're off, yeah.
Yeah.
So we were just saying it's nice to come back for 4 days. Yeah.
4 days.
That's right.
You guys have a good weekend.
Thanks, Cam. You too. Nice group, but a quiet group.
Yeah.
Like my calc classes but they tend to have a lot of the same classes together, so they know each other a lot more.
Yeah. Obviously, those kids are going